Welcome to the Modern.NET Show, formerly known as the .NET Core Podcast. We are the go-to podcast for all .NET developers worldwide, and I am your host, Jamie Geprogman Taylor. In this episode, I spoke with Brian Kostelnich about both IoT and Wilderness Labs. We discussed what IoT actually is and the many differences between developing systems for IoT devices and developing modern .NET applications which run on servers, desktops, and mobile phones.
Yeah, it's funny. It's one of those terms that is so broad and encompassing. I mean, really, Internet of Things. So things that are connected to the internet, and really, what does that mean? Is your TV an IoT device? Well, maybe. Is your car an IoT device? A lot of these cars today are connected to the internet. In our world, and I think colloquially, what folks generally accept as IoT are non-standard compute devices that are typically embedded, so they're often small and deployed to the field generally, that are connected devices, right? And typically this means an embedded device, a device that is powered by like a microcontroller, sometimes a Raspberry Pi, which is really just a small computer. But generally, anything that is a what we think of a thing, connected things or small devices.
So let's sit back, open up a terminal, type in .NET New Podcast, and we'll dive into the core of modern .NET. So, Brian, welcome to the show. I really, really appreciate everyone who comes on the show, and we're going to talk about some stuff today that I have absolutely no idea about. So I'm coming into this with, nothing. So I apologize for that in advance.
Sounds like fun.
Oh, I'm sure it will be. So would you mind introducing yourself a little bit, talk about yourself a little bit, maybe an elevator pitch, and talk about Wilderness Labs as well, please?
Sure, yeah. So my name is Brian Kostelnich, and I am co-founder and CEO of Wilderness Labs. And Wilderness Labs is a company that I founded with some friends back in 2016. And I started Wilderness Labs after we sold Xamarin to Microsoft, right? And at Xamarin, we brought the .NET developer platform and the ecosystem, of course, to mobile, right? We enabled .NET developers to use their existing .NET skills to build mobile apps, and sort of the rest is history there. And we started Wilderness Labs with kind of a similar idea. The idea being that you've got a bunch of .NET developers out there, and there was this emerging market. This sort of the new epoch of computing was moving from mobile to being able to put computing in everything, everywhere. And traditionally, that if you wanted to, sort of participate in that meant that you had to write C or C++, and
sure.
And we wanted to bring .NET to that space. And so our mission is to make building and maintaining hardware as fast and easy as web or mobile development, which is, kind of a lofty goal. And so that's why we created it. We just wanted to enable .NET developers to do things in the hardware space and make, real physical things.
Okay, cool. So then obviously there's this direct lineage, I guess, from presumably Mono into Xamarin, into Wilderness Labs, into .NET on IoT devices, right?
Yeah, that's right. That's exactly it. So, .NET was created back in 1999-ish, and released in 2001. And a few years into it, Miguel de Casa started hacking on an alternative open source .NET runtime for Linux, right? Because originally Microsoft didn't, they really didn't want to participate in the Linux ecosystem. Ballmer thought of it as a threat. So did even Bill Gates, at the time. And what happened was that Mono was incredibly successful, and those guys really brought .NET to exotic platforms. The original .NET was really tightly coupled to Windows. It was built on a lot of the Win32 APIs and whatnot. And what Mono did is really abstracted that and let it run on Linux and eventually non-Linux platforms as well. So iOS, Mac, and Android, which is, of course, Linux based. And that, became wildly popular. And Microsoft, in the meantime, also changed its open source perspective. And what happened was that Mono eventually, as we got acquired over at Xamarin, Mono and .NET really got merged, right? Because .NET would only run in the Windows environment, but .NET is really useful everywhere. Now you can do .NET just about anywhere, right? You can write web apps, you can write mobile apps, you can write cloud apps, you can write games, and now with us you can do full .NET on microcontrollers. And so our lineage is directly in line with that. We really run on the Mono .NET unified platform.
Okay, because that was going to be a thing that I was going to bring up, but I think you've already answered. I was going to ask about how does, we'll come into what IoT and all that kind of stuff is in a moment, but because you've said you've got this direct lineage back to Mono, does that mean that it's not modern .NET, that it's still Mono, or is it .NET framework but with bits trimmed out? How does that work?
Yeah, so it is modern .NET. We're not on .NET 8 yet, but we're working on that port. But we do support .NET Standard 2.1, the equivalent, the .NET Core 3.1 runtime is basically what we have, and what we have under the hood is that it's effectively the Mono runtime with a bunch of the .NET 8 stuff pulled into it, or in .NET 6, because we also have a JIT backend, which is something that doesn't really, a JIT backend for Thumb 2, which is what are the initial board microcontroller architecture is, right? And so in order to support that, there was a bunch of work, and we actually pulled in some of the latest and greatest in .NET 8 so that we could support some of that, the JIT magic there and some of the AOT magic. But yeah, it's full .NET. You can go and grab NuGets off NuGet.org, and as long as they support .NET Standard, they should basically run on our hardware. Now, bear in mind, there's still a limited resource or a resource constrained device, so there's things you have to do when you're coding to think about that. But generally, modern .NET just works.
Cool. So I guess then, just using a silly example, I probably don't want to pull down the entirety of Newtonsoft JSON, right?
Actually, Newtonsoft JSON does run on our platform. Newtonsoft JSON is a little bit memory heavy, so we generally say use system.text.json. But you can get Newtonsoft running. But it does if your app is doing a lot of other things, you'll find that you might get memory constraints on there. So there still are things that you need to think about, but generally things work.
Oh, awesome. Yeah, because I should have been clearer. That's kind of what I was alluding to. If you're writing something for a teeny tiny board with, say, I don't know, I'm just going to pull some numbers out the air, 2 or 3 megs of RAM. 2 wouldn't work, but maybe 8 megs of RAM or something like that, right? A tiny amount of memory. You probably don't want all of Newtonsoft JSON because that's massive. I don't know whether that tracks, but I'm just pulling numbers out the air there.
Yeah, no, that's right. And we actually ship a board that has 64 megs of flash and 32 megs of memory of RAM. So that actually gives you quite a bit of overhead, quite a bit of headroom to run apps, modern .NET apps that do a lot of things. And that's really interesting because for our customers, our customers are really doing more complex apps in the IoT space generally. They are writing things that basically what they're doing is taking a lot of the patterns and practices that they do in like a mobile app or a web app in terms of like, saving locally on a SQLite database and using HTTP client or HTTP request and building up those, and to do RESTful communications on the web, etc. Right? Like all the things that you would, and threading and using tasks and all of those modern patterns that we're used to with web or mobile apps. That's what we encourage you to do on our app, on our platform, because that's just a super productive way to code, and you don't really have to worry about a lot of the low level stuff and fighting with like, okay, well, we got this buffer in memory someplace and I'm going to swap data in and out and it's going to be a shared buffer because I only have 60K of memory or RAM or something, and I've got to do all sorts of like crazy finagly bits just to make this work. With our platform, the idea here is that you don't really have to do that. This really is a modern platform and a modern way to do hardware, and you write apps as if you were generally writing other .NET apps.
Okay, that and I guess that makes sense, right? I guess as a developer, if I need to write something that's going to run on an IoT device, we'll come back to what IoT means. And if I'm going to use a Wilderness device, I want to be able to use the conveniences of .NET. I want to be able to use like dependency injection and all of the stuff that requires a little bit more setup, a little bit more like stuff with reflection and things like that. And like you said, being able to perhaps run a small database on the device as well, just for temporary storage whilst I'm sending stuff out. That makes sense, right? Being able to store all of that stuff.
Yeah, 100%.
Cool. Okay. So I guess for the devs who are like me, who have no idea about what actually IoT means. I mean, I know it means Internet of Things, but like what it actually is. So what is, because like in my experience, an IoT device is an Arduino or a Raspberry Pi. Is that correct? Is that not correct? What is IoT?
Yeah, it's funny. It's one of those terms that is so broad and encompassing. I mean, really, Internet of Things. So things that are connected to the internet, and really, what does that mean? Is your TV an IoT device? Well, maybe. Is your car an IoT device? A lot of these cars today are connected to the internet. In our world, and I think colloquially, what folks generally accept as IoT are non-standard compute devices that are typically embedded, so they're often small and deployed to the field generally, that are connected devices, right? And typically this means an embedded device, a device that is powered by like a microcontroller, sometimes a Raspberry Pi, which is really just a small computer. But generally anything that is a what we think of a thing, connected things or small devices. I kind of come at it from the perspective that we've really changed how we think about computing in terms of computing power or computing location, right? So if you think about this in historical context, computing really started, we think about like mainframes, and then those shrunk up and we got personal desktop computings, and then the internet hit, right? And then the internet was a huge epoch, and then the internet sort of turned into cloud, and mobile hit, and then and this is sort of the next phase of computing. All of those epochs were really about making computing more miniature and being able to use it in new places. So the mainframe to personal desktop revolution meant going from a giant room or a building into, something that sat on your desk. And then when mobile hit, that meant that we moved that from our desk to having a supercomputer in the palm of our hand. And with the embedded revolution or the IoT revolution, really what that means is now we have that same class of computing of really like what I would say is capable computing, right? Because if you look at the microcontroller on our board, it's an STM32F7, and that has about the same processing power of a Pentium, and yet it's the size of my pinky nail, right? It's very, very, very tiny. And it's also incredibly ultra low power, which means that you can run it on a small battery. And so those two things mean that you can now put computing anywhere. And that's really what I think about in terms of IoT. I think of the idea that you can take computing or take compute and you can put it anywhere. And there's a little bit of a fuzzy, sort of gray area here in the sense that okay, that's true for microcontrollers. It's not necessarily as true for single board computers like Raspberry Pi. Right, so there's this sort of class or distinction in classes of computing when you talk about microcontroller versus a CPU in a single board computer like a Raspberry Pi, whereas a microcontroller is really an all-in-one. It's got everything that you need in terms of what you look at a motherboard. Everything is in one chip. It's the processing processing chip. So the CPU, it's the memory, it's the flash, and then it's a bunch of hardware I/O and hardware control so that you can plug sensors and peripherals and drive motors and things like that. That's kind of all in one, right? And that's a microcontroller. And as you go up the computing stack, the next thing that you find is like app processors or CPUs. So what you find in mobile devices or what you find in a Raspberry Pi, and that's really a dedicated CPU, and then you have to add on memory and flash, and some of those may or may not have a microcontroller in them, which adds the additional hardware I/O control. But when you move up to that next class of computing, then you start to look at a totally different power profile. So a lot of these, just to give you kind of a sense of the power consumption, a microcontroller, for instance, uses somewhere between 1,000th and 100th of the power that you would consume in a Raspberry Pi. And so that means that when you're running from battery or solar, you've got a completely different footprint, right? So you can run from a tiny little battery on a microcontroller, whereas to run a Raspberry Pi for any length of time, you're really starting to think about it like a mobile phone size battery, those charging like the Mobi packs, or almost like a laptop battery. And so that makes a big difference in where those things can get installed and the sort of use cases that they are applied to. But they're both oftentimes used in IoT contexts, right? And it really depends on what you need in terms of your use case. For instance, if you look at running AI at the edge, you can do, there's quite a lot of AI processing that you can do on a microcontroller, like vibration analysis, fast Fourier transform, FFT, even some image recognition, etc. That's all completely doable on a microcontroller. However, when you start to switch to video processing, especially high definition video processing, now all of a sudden you need more processing power. You need more hardware, and oftentimes you need a GPU involved, like with a Jetson Nano. But I really still think of those devices, depending on how they're installed, really, and this is really about installation context or use case, those are still IoT devices. If they are things, if they're standalone things that are connected to the internet and are doing, solving some problem, I think that those are really IoT. And I think that personally, I draw the line between that and a car or maybe large computer installations, etc. Sometimes we talk about things computing at the edge, and there might be an edge server, and that may be a gateway, or that may connect to a bunch of IoT devices, but that's not really IoT to me, or I think, generally accepted, that's not really IoT.
Sure. Okay. So it's more the the end devices that are, let's say I'm pulling an idea out the back of my head. Let's say I have a series of vats of some kind of chemical or some kind of compound or something, and I want to check on the temperature. I could perhaps take maybe a Wilderness board, maybe an Arduino, maybe some kind of other microcontroller based system, put some code on there that just says every 10 minutes, take the temperature and then send it off to this address, right? That's more of an IoT kind of device and situation, I suppose, rather than, I have my Raspberry Pi sitting there and it's, serving me files, it's a web server or whatever.
Totally. Yeah, that's the 100%. And it's really about context. And also, one of the things that I think about is like some people say, oh, well, a car is an IoT device. It's like, well, a car is really an ecosystem of IoT devices and other things, right? So you could think of a car as an IoT installation site that's mobile. But like in your case where you have vats, maybe a fermentation vats or something, maybe you're making beer at in an industrial scale, and you've got a bunch of little devices doing single things, or maybe a small set of things and then orchestrating in some sort of larger context. Those are all IoT devices for sure. And that's an interesting point because a lot of these IoT devices they may be installed in a standalone capacity, but they're not working in a vacuum, right? Oftentimes, IoT installations might have tens or hundreds or even thousands of devices. So I heard a quote from someone that a modern oil rig, for instance, has tens of thousands of IoT devices, right? And so that's an interesting problem space because IoT to me is interesting not only from the hardware design aspect and the actual use case and interacting with the real world, but also the other side of that, which is that these things are often installed in groups and have an orchestration aspect where there may be a big data backend, there may be a digital twin where hundreds of devices feed real-time information, and up in the cloud or on a device in your hand, an iPad or something, you may have some digital representation of the real life of whatever that real life installation is. And that to me is super interesting because now it takes it away from just the single device installation to, oh, this is actually giving me live metrics, live data of some sort of installation, some sort of thing in which there is orchestration and there is backend and there is all that integration.
Okay, So using your example of a car being kind of like an IoT installation site, and what you've said about orchestrating all of the information coming from lots of different devices into maybe a dashboard or maybe a data store, what I'm seeing in my head is if a modern car is like an IoT installation site, then perhaps my dashboard on the car, like the literal dashboard showing me what's happening, showing me maybe brake temperatures or showing me, my the engine's revs per minute count or the amount of gasoline it's got in its car. That's essentially kind of what you were talking about there with like pulling all of that information together, communicating with all of those devices, perhaps in real time, all those devices posting and saying, hey, I've got an update, publishing and pub-sub sort of stuff, publishing, subscribing. That's way different to anything I've actually ever done in my career, which is essentially forms over data over the web.
Yeah, that's right. And actually, that's a really interesting example because what you've just described is what we call an HMI, a human-machine interface. And just as you have a dashboard in your car, oftentimes, like at an industrial site, you'll have dashboards around equipment, or you'll have centralized dashboards at a desk or something where you have a screen and someone can sit there and they see a bunch of that real-time information from the devices around them displayed, right? So same sort of dashboard where you have gauges, you have, you have your oil pressure and oil temperature. You might have the same sort of thing with equipment, etc., right? And so that's like a human-machine interface, and that's kind of a local display of that information, right?
Sure. Okay. So then, I'm just sort of trying to extrapolate from that. Then, so does that mean then IoT in industry is different from IoT commercially? Like if I'm buying, or if I'm building something for myself for a personal project, is that a different kind of IoT? Hopefully, everyone can hear the bunny quotes there. To like the IoT used in industry as a HMI, or maybe just to collect some data, or maybe I've got one that's sitting in a field somewhere that's collecting I don't know, atmospheric data or whatever. Is it a different kind of IoT, or is it all the same?
Yeah, so that's a super interesting question. So what's interesting here is that we generally break this down. We break IoT down into three different market segments, which is industrial, commercial, and personal, or it's not residential. It's like personal IoT, consumer IoT. There you go. Sorry, industrial, commercial, and consumer IoT. And by breakdown, this is really, really interesting because we often think about like computing revolutions as things that are sort of in our face, right? When the internet happened and we all started saying .coms and we started getting connected to the internet and things like that, we had a real hero experience on our desktop machine. And when mobile hit, we got a supercomputer in the palm of our hands. And so we had a hero experience in the palm of our hands. And so those revolutions were really, really apparent. And what's interesting about the IoT revolution is that it's really a quiet revolution, because while there is consumer IoT, smart fridges and smart toasters and things like that, Ring and Nest, that's like a tiny fraction of the overall market. So by our market estimation, our own research, it looks to be about 60% of IoT is in the industrial space, about 30% is commercial, and 10% is consumer. And just to break that down, when we talk about those things, when you say consumer IoT, it is things that consumers would integrate with, would consume, would interact with. So smart thermostats, smart appliances, things like that. And then when you move into the commercial space, you're talking about med tech. So medical technology, you're talking about smart buildings and asset tracking and commercial use, commercial scenarios, etc. But by and large, the biggest place in which IoT is installed is actually in the industrial sector. And that is industrial processing, that's logistics, transportation, that's agriculture, ag tech, manufacturing. And so the IoT revolution is this massive, massive quiet thing where we don't really see, we just see the tip of the iceberg. And what I find super fascinating about this is that oftentimes what we see is that we see the same solutions over and over in terms of like the hardware solution with different application and installation contexts. So a lot of the IoT that you see, for instance, within like industrial or commercial, a lot of them are from a hardware perspective are often very similar, but the applications that run on them and the installation context is pretty different. And we see that a lot with our customers. Like we've seen some version of a smart pump over and over and over, in which you've got a valve, an IoT controlled valve, maybe a flow sensor, and maybe like a distance sensor that measures how much liquid is in a container, right? And that could be a cistern, it could be in a well, and it could be then, you control a valve and then you measure flow. And we've seen that over and over and over in a bunch of different contexts. So you might have a well monitor, you might have a propane tanks, propane storage monitor, you might have a smart pump. We've seen this in emerging markets where in Africa they're providing access to water sort of in a pay-as-you-go use case. And that, again, that's like a smart pump. And so what's interesting about this is that you see the same hardware solution over and over, but what you have is very wildly different applications that run on that and different contexts.
If you're enjoying this show, would you mind sharing it with a friend or colleague? Check out Podcatcher for a link to the show notes, which has an embedded player within it and a transcription and all that stuff, and share that link with them. I'd really appreciate it if you could indeed share the show. But if you'd like a few other ways to support it, you could leave a rating or review on your podcatcher of choice. So if you head over to .netcore.show/review, you'll find loads of ways to do that. You could consider buying the show a coffee. The Buy Me a Coffee link is available on each show's show notes page on the website. This is a one-off financial support option. You could become a patron. This is a monthly subscription-based financial support option, and the link to that is included on each episode's show notes page as well. I'd love it if you could share the show with a friend or colleague, or leave a rating or review. The other options are completely up to you, and are not required at all to continue enjoying the show. Anyway, let's get back to it. Okay, so I know from a previous project that I was attached to, I wasn't involved with the potentially IoT side of it. We'll find out whether it's IoT in a moment. But I was building a dashboard that exposed a bunch of data to people who were authorized to see it. This company were involved in large scale logistics. Mm-hmm. And what they wanted to do was for a container. I'll just say a container, right? Because that you can put some stuff in a container, and then they would slap on it a low powered, maybe an NFC or something like that, or maybe an IoT device of some kind, some microcontroller that would be able to. It would have some kind of persistent connection to the web, and it would be able to post away to someone, hey, I am in this location now. Hey, I am in this location now. And I am in this location. They also then extended that to have like smart contracts. So you could just take the container, dump the stuff in it, attach the device and scan it and say, that's my contract. Whoever needs to pay for it, pick it up, can then, do whatever smart contracty things need to do. But then they could track that package throughout wherever it went in the world. They could then see where it is in the distribution centers and stuff like that. I feel like that's perhaps way off coming into the individual consumer sector, because obviously if we're putting every single package that it wasn't Amazon, but let's use Amazon as an example because they're the biggest e-commerce company that I can think of. If Amazon decided to put these IoT devices on every single package, that could get kind of wasteful. But for large scale distribution and logistics, it made sense because they could reuse the device, right? But would you see that as IoT? Was I doing IoT and not realizing?
Yes, 100%. That is like a classic IoT use case. Putting something on a shipping container that takes a GPS, receives a GPS signal so it knows where it's at, and maybe it has an e-paper display on there or something that you could, with a QR code, you could scan, which might bring up information on the web about the manifest, and then it's updating in real time. It's location, maybe some conditions within the container, like if they're shipping bananas, there might be a temperature and humidity sensor in there, and that's also feeding that up to some dashboard. That's 100% IoT, and that's a very classic logistics IoT use case. And what's interesting there is that you could take that same solution, relatively speaking, that same hardware setup, and you could put it in a different context. You could put that in a building and attach it to some expensive piece of medical equipment. And now all of a sudden you've got effectively the same hardware, but in a totally different context, doing commercial IoT, doing medical, or doing smart asset management, building asset management. Again, totally IoT, same hardware, different context.
Right, I see. That personal side story, and looking behind the curtains, hey, Mark, the editor, you can keep this one in, giving some stuff away from the listeners there. I recently had to take a trip into the hospital walk-in center. There was nothing wrong with me. There was, but it was not serious. They needed a piece of equipment to do some kind of check on me. They couldn't find the piece of equipment. Perhaps if they had commercial grade IoT devices, they could have tracked where that piece of equipment was instead of having me wait for 3 hours whilst they found it.
Yeah, 100%.
Cool. Okay. Okay, as a forms over data web dev, I guess, what's my story for interacting with one of these devices? Like, is it like am I having the thing post out to me like over the web? Do they work with the cloud? Right? Because I don't know. So you've said it's like a microcontroller. So I'm thinking because like a little bit of background history on me. When I started my college education, so over here in the UK, 16 to 18 years old, so I guess the final few years of high school in the States, I was actually playing around with a lot of microcontrollers. I actually got to use a Flight 68K, which is a Motorola 68K CPU, and you could plug it into a Windows machine, drop out to DOS, write loads of code in C and or in assembler and watch it actually run on the device. So if I'm constrained, my ability to send data is going to be constrained, right? You were saying earlier on about sometimes HTTP client is a great thing to be able to use in .NET, but maybe that's memory intensive. We know from our earlier conversation, Newtonsoft JSON, you probably don't want to use that. You probably get away with system text JSON because that's probably a little bit smaller, or maybe there's another library that does just serialize and deserialize. But like, as a developer, what's my story posting out to the cloud or like server side stuff if I'm collecting data, or even if I'm pushing it out there? Is that a confusing, difficult place to be? Because I can imagine prior to you guys doing the work that you did, it was all low level C, right?
Yeah, so there's kind of two different stories there, right? There's our story, and then there's sort of the rest of the marketplace. And our story is, listen, you can connect to the cloud in a number of ways, and you can get your data up into the places that you want a number of ways. The first one is that you can directly call to the cloud. And when you use our platform, you get a full network stack, and there's no you're not locked into some proprietary messaging format, right? Like there's a lot of different things out there, but there's like, for example, Blues Wireless is a thing that you can plug in and you get cellular connectivity on existing IoT or microcontroller devices. But what you get is a proprietary messaging format, and then it goes through their server and it's very limited, right? Like, and then there's other solutions like you can use Particle. And Particle, you basically post to their cloud and you get these little tiny messages where you can send one piece of data and then it brokers on, etc. Right? So there's a lot of different ways to do this. But with us, the idea is, listen, you can do it any way you want. If you want to just connect directly, open up HTTP client and make a RESTful request, or even SOAP or something, you can, right? You just open up a connection to the cloud and send it on. You can also use our cloud integrations, in which we handle all of the basically what happens is that you can use a log provider, and you can just say, logger.log, and here's a message. It can be JSON, it can be a blob, whatever you want, and that will save locally, and then when there's connectivity, it'll cache it locally in a SQL database, and then when there's connectivity, it can upload on specific intervals and batch things up, and that'll send it to Meadow Cloud, and then there's a bunch of integrations, so you can automatically forward those on to things like Azure Event Hub or DataCake, or any number of other places where you might want to send that data. So we offer really both ways. And from a .NET developer perspective, you can do whatever you want. You've got a full network stack, and that network stack is available to you whether you're connected via Wi-Fi, via Ethernet, via cellular. It doesn't really matter. It's all you just have a network connection, and you can go at it and do whatever you want. So from a perspective of like a .NET developer, there's not really a lot to think about here, in the sense that like you just program the way that you ordinarily would program. And because we've got .NET and we've got a really advanced runtime, things that are either incredibly difficult or just outright impossible, like, try to do threading in Arduino. It doesn't exist. You can't do multiple threads in Arduino. But like, unless you go down to really, you start going to like full C++ and use things, use the things that are available there. If you're writing Arduino wiring code, you just don't have that. But in our platform, you've got threads, you've got tasks. So you can do async await, and you can, shove things off on a background thread, and you can you can spin up a task, etc. So it's really the same from a .NET developer perspective.
Okay. So if I've got the full .NET stack with a Wilderness Lab device, right? I know from the early days of IoT, I feel like it became a bit of a meme, and it was a bit mean to do this, but I feel like a lot of the early IoT adopters who were like, quick, let's just release loads of stuff. Those developers were perhaps desktop or web developers who were then given this device, not one of yours, I must say. They were given a random piece of hardware and told, create a Linux distro and write an app that sits on there, and it doesn't matter about security. So just send all that. Yeah, right. I remember there was a story about an IoT light bulb that you could connect to your home Wi-Fi network and control it from an app on your phone or whatever. Oh, I'll have a green light today. I'll have a yellow light today. But then it's then an attack vector into your network because it itself wasn't secure. So I feel like it was a bit mean to pick on these developers because obviously their job wasn't IoT or embedded systems, but they became embedded systems developers. So I guess my question here is around security with IoT. Is it even possible to do like TLS, or is everything just you going out of a plain text web requests, just HTTP, right? What's the deal here?
Yeah, that's right. Historically, IoT devices have been woefully insecure, and really, I suspect that the majority of installed in situ devices today are basically either have minimal security or none at all. And to your point, most devices out there don't even support TLS. They don't support, SSL or HTTPS. With our devices, that security was a priority zero for us. A lot of our customers are building critical infrastructure. They're doing things in defense contexts. They're doing things in enterprise contexts where security is absolutely essential. And we think of that as a table stake, right? That's something that even just to play in the space, you need to be secure, and you need to be secure by default. And so for us, security has always been a driving force of the architecture and implementation of our platform. So absolutely TLS is supported, and it's, that's the default. So you talk over SSL. Everything that we send to the server, we have device to server is completely, 100% encrypted. When you do over the air updates on our platform, all of those packages are not just encrypted, but they're actually signed with, they're encrypted with the device's public key, so only that device can decrypt it, and then there's a secure boot, so you have to match, the package is signed and has to match the keys that are on device. You can't just sideload an application. So yeah, we've thought about security really from kind of from hardware on up, because for our customers, that's really a priority zero, and for them, like I said, this is table stakes. They can't even install or deploy a device if it's not going to have a default level of security. And like I said, most devices out there, most platforms out there don't have that same security level or same security posture. For instance, most IoT devices out in the wild today, and most that you would buy today, don't even support SSL. Right. And so that's super important to us.
Sure. And I feel like that it kind of goes a little bit. I'm not trying to excuse the lack of TLS in the wider world outside of .NET IoT and Wilderness Labs hardware, but it feels like it's related to, like I said, a bunch of software developers suddenly became embedded hardware developers, and they were like, we've got angel funding and we need to release the product to the world tomorrow. get it working and we'll fix it later.
There's also a hardware challenge here, right? Which is that hardware is still catching up with the use cases that folks want to solve. So a lot of the hardware is kind of a race to the bottom, because especially in like consumer IoT contexts, everything needs to be as cheap as absolute possible, right? And so when you do that, you start to use devices that have less memory and less flash, and even storing certificates. Certificates add up pretty quickly, and certificates needed for SSL. And so a lot of devices don't even have that. They don't even have the storage capacity for that. And also a lot of those things are add-ons. And that's one of the challenges of doing hardware with traditional platforms, is that everything's so piecemeal. You pick a micro RTOS, a micro real-time operating systems, an operating system that runs on one of these microcontroller devices, which is, not Linux. These are even smaller than that. And then you have to say, okay, well, if I want TLS, I have to go find a TLS library. So I find embed TLS, and then I fight with CMake and configuration files to get that compatible with my OS version, and then I need these other things, etc. And it's very a la carte, but then you have to compile it all at once. There's no dynamic loading. A lot of these devices don't even have a dynamic loader. That's a convenience that we don't even think about as .NET developers, DLLs. And when you're writing software for these devices, all that stuff has to be baked into the very beginning. And like I said, you quickly run out of space on these devices. I have talked to many customers who had installed some microcontroller out there, and if they want to add a new feature, they have to delete another feature, right? They're always sort of like swapping around memory and whatnot. And so what's happening now is that these microcontroller devices are starting to get more powerful, and they're starting to match the use cases that folks need for them. And so we're at a real sort of turning point, or a real inflection point in IoT, in which the hardware is finally catching up in terms of their capability and matching the use case or scenario that folks need to build apps for. And so a lot of this is just historical legacy reasons that these things don't exist. And then the other side of it, like I said, is just the software side. And that's what makes hardware hard. It's not the hardware generally. It's writing the applications. It's building these, building the software, because you exist in such a low level place where so much of this tooling and whatnot is so primitive. I mean, embedded C really hasn't changed in 40 years, right? And you're still, if you want to write something in embedded C, you're still fighting with like all these low-level make files, and trying to get your operating system up and running, and then trying to find like all of these things to be compatible with it. Like, okay, I want to add SSL, so I need to go find a compatible TLS library, and it's just a headache. And then if you want SQL, okay, I got to go find that SQL, and I got to go find one that's compatible with this OS, and I got to get built in and stuff. And for us, all that stuff's just baked in from the get-go. And so what we've built really is more like what you would be familiar with in like a mobile OS in terms of features and functionality, but running on a microcontroller, so you get those just out of the gate and you don't have to really think about it.
So we'll come back to hardware being hard in a moment, and I've got a question about like where is IoT going? But there was something you'd said there about if this, you were speaking to particular customers who were saying previously with non-Wilderness boards, they may have had to remove a feature to add a new feature. And you reminded me of, I mentioned it earlier on, the Flight 68K, the Motorola 68K boards, which I think had 32K of RAM. They may have had way less than that. But that would have been like total system memory. I remember having to map out the memory that I was allocating for the project I was working on, because I had to get another 2K from somewhere. I was like, where am I going to store this data? And so you brought back that memory for me. So I want to thank you, I guess, for that.
The PTSD, having flashbacks. Yeah, I really appreciate that, Brian. Thanks. No, that's a common thing. And we hear that from our customers a lot that are, using, that are building on these legacy microcontrollers and whatnot. They want to add a feature. They literally there's a big memory map, and in this memory map, it's like an old Atari video game or something. There's a big memory map, and that's where your features go. That's where the data goes. And if you need different features, if you need to store some different data, then you've got to juggle things around. And that is just, it's absurd to us as modern developers, right? Like when have you ever considered anything like that, writing a web app or a mobile app? Of course not. That's just insanity.
Mm-hmm. Yeah, because we have, oodles of RAM, oodles of space. Storage space for us is infinite almost. Because we've also got an operating system that will do like swapping of stuff out, right? So you start to allocate too much memory, then something that's not being used will be dumped to the hard drive to then give you more memory to play with because you've got swap space in your OS. And then I guess before it even gets to that, you've got the garbage collector, right?
Yep, that's right.
Yeah. Oh man, yeah, it's yeah, you're reminding me of those times. So where is IoT going then, in your opinion? Is it going to change the world? Are we all going to be... Because peeking behind the curtains, listeners, I'm using an M2 Mac Air, which is an ARM chip, which, crazy thing, 5 years ago, I'd have thought that Apple would stay with Intel, but here we are, right? So is the future eventually going to be, we're not going to have a computer, we'll have a bunch of IoT things that communicate with a slightly more powerful thing to help us do our daily tasks? Like, what is that? What's the future look like?
Yeah, I think that's an interesting question, right? There's unpacking it. There's a couple of things there, which is how do we interact with compute? And that's super interesting because while you and I are sitting here on a desktop, and that's still a relatively common compute scenario and a place in which certain use cases are really only possible. A lot of, you look at like generationally and in the workplace, you look at like young kids today don't have computers. They have mobile phones, and they do 95% of their compute on a mobile phone. And maybe they might go to a computer just to type out a paper or something, but like most, a lot of folks these days, their compute interaction has shifted from a desktop computing context to a mobile phone. And the thing about IoT is that the promise of IoT is that it can make a lot of this compute sort of just transparent, in the sense that like everywhere you go, you might interact with compute, and might interact with your phone, and might interact with like your presence, but you don't really even have to think about it. And so that is kind of an interesting question. It will be, and I don't have an answer here except to say that, well, as compute gets moved into contexts and places that we never really considered before, the world will change in the same way that the world changed with mobile. I mean, I can't even imagine driving on a road trip anymore without a mobile device with Google Maps, right? I mean, that drastically changed how we interact with navigation and how we see the world. And that was all because of the mobile revolution. And the same thing will happen with devices installed, basically everywhere. But the thing but the other piece of this to unpack is like, well, how is it actually changing the world today? And that's super interesting because, like I said, IoT is the quiet revolution. But what's happening is that in industrial contexts, IoT has already made massive changes and will continue to make massive changes here. So if you look at like agricultural technology, ag tech, you look at productivity gains in food production, for instance, you're seeing that smart agricultural setups can now produce a lot more food for much more efficient resource, input. So you can maintain and manage soil chemistry and moisture in a much more efficient way without wasting fertilizer or wasting additional watering. Or in industrial scenarios and industrial manufacturing contexts, we've seen it already making huge differences there. So you have bolt-on IoT devices that listen to device vibration and noise and energy usage and can tell you, hey, listen, this giant machine here, which has, X number of motors, we detected a vibration of this particular frequency, which tells me that this motor has a bearing that needs to be replaced. And if you schedule some preventative maintenance, then you can do that. You can take the downtime in night when the device is, when the manufacturing is offline, and then you won't have unexpected downtime when this motor fails. And stopping your production lines, right? Or same thing with frequency. You can listen to CNC machines and the chatter, and they can, as they're milling parts, it can automatically slow down the mill as it hits chatter and stuff like that. So what that does is it extends the tooling life and makes things much more efficient. And so we're seeing productivity gains, massive productivity gains already in industrial scenarios. And what I find really heartening here actually is that, like, if you look at resource usage and pollution and things like that, and things that we're sort of dealing with climate change and the Anthropocene, 70% of all resource usage goes to industrial processing, right? So if you can make modest efficiency gains in massive industrial processes, then that can drastically lessen our impact on the planet. And so that's really heartening to me. I see IoT really helping us out in our battle against, our impact on the planet and being more efficient and being sort of better stewards. And then we're also seeing super interesting things happen in like emerging markets. So just as the mobile revolution democratized access to computing, basically if you go to sub-Saharan Africa, what happened over the last 15 years is that folks that never had access to computing or computers, now they all have a mobile phone, right? And so in these emerging markets and these developing nations, you're actually seeing democratized access to not just compute, but resources. So we have a customer that does a lot of stuff that does a lot of stuff around resource access. So pay-as-you-go solar and pay-as-you-go water and things like that really democratize access to scarce resources in these emerging nations. And what's happening is that these folks are getting access to these resources in a way that's sort of communal and shared in a way that they weren't able to before, and they're able to sort of participate in the economy, and they're able to sort of participate in society as a whole in a larger context than they were before. So we're really seeing IoT change the world in a lot of different contexts. And of course, like even at our house, I mean, so many folks have smart thermostats now. Smart thermostats will help make heating and cooling much more efficient. So we're seeing that even in our own personal lives. So yeah, we're seeing, I think we're seeing the impacts of IoT really all over the world in a lot of different contexts, and largely, they're seeming to be very positive.
Sure, yeah. I mean, you talked about smart thermostats. I've got a smart energy meter. So that's reporting electricity, gas, water usage back to my providers, but also I can see that data too, right? So I think I think you're right. I think it's starting that. I think you said quiet revolution. I think we're definitely in full swing of it, right?
That's right.
Awesome. So I do know we're running low on time today, but if you're interested, I would love to have the Wires Hardware Hard conversation with you, perhaps another time, on a day and time when you've got more time, because I feel like that's a from the points you've raised so far, I really want to dive into that and say, like, well, what makes hardware hard, other than just picking the right operating system and the right libraries and stuff. But I guess the big question that I want to ask is, let's say I've got this idea. Maybe it's a personal project, maybe it's a project I'm working on for the company I work for or whatever, and I'm like, I want to do IoT, I want to do .NET. Where do I go to start doing that with you guys' stuff? Is it just, wildernesslabs.com and just like push a button and then file new project? Like what's the learning curve, I guess? How do I hello world?
Yeah, so I would say, so first of all, you can find us at www.wildernesslabs.co. So that's where you can find more information about us. And if you want to start building, what I would say is go to our store, go to store.wildernesslabs.co, and pick up either a dev kit or, a Feather, or pick up a project lab and just start building, just start playing. The thing that I often recommend to folks is to get a project lab, which is kind of an IoT in a box. It's a microcontroller based prototyping platform that has a bunch of built-in sensors, and it's got a bunch of built-in I/O, and you can basically it has Seed Studio connectors, it has microbus connectors, it has Adafruit connectors, so you can go to Adafruit or Seed Studio or SparkFun or Microelectronica, and you can buy any number of from thousands of different peripherals. You just plug them in. There's no soldering, there's no breadboarding, and then we have drivers for basically everything out of the gate. So it's very plug and play. And just start building. Pick a project and just start to hack on it. And join our Slack. There's a link to our Slack at the bottom of our website. Come in and talk to us. But yeah, just start building. Get a project lab board. Figure out what you want to build, plug in some stuff. And by the way, there's also a bunch of stuff already built into the Project Lab board. So there's a bunch of onboard sensors. There's a light sensor. There's an IMU or a 9-axis accelerometer. There is a temperature, pressure, humidity sensor on there. There's a big screen. There's a bunch of buttons, so you can do HMI. So it's already a fully packed board, and it has like an RS-485 connector, so you can plug in industrial sensors. There's a bunch of stuff on there, and I would say just start to build. Just grab one of those, pick an idea, start to build. We also have a pile of samples up on Hackster. So if you go to our website and then you go to our documentation page, there is a big link. If you scroll down, it says View Projects on Hackster. There's a ton of cool projects on there to provide some inspiration and kind of see what you can do. But just start building. And if you run into challenges, come talk to us, because we've got a really great community. Just like the .NET community at large, we have a really positive and supportive community, and folks really like helping people and seeing people succeed. So, come and chat and run ideas past us, and we can, past us in the community, we can help you with those and give you pointers and get you rolling.
Awesome. I really like that. I may have to check out the store myself and pick up one of these lab boards, because I've got to get the kids interested in programming somehow. And if I can get a box that they can poke at and see stuff happening, then that would be brilliant. Get a humidity sensor for the house, or maybe a temperature sensor for some of the things that the kids are growing in the garden and stuff like that. That'd be cool. Awesome.
Fantastic.
Brilliant. Well, I guess for now, for the short term, Brian, it's been wonderful chatting with you today, and I just want to thank you for enlightening me and giving me that, I don't want to say PTSD, but that flashback of remembering that thing.
Yeah, absolutely. It's been a pleasure. Can't wait to come on board on the show again and talk about more stuff.
Awesome. Thank you ever so much. Thank you for listening to this episode of the Modern.NET Show with me, Jamie Taylor. I'd like to thank this episode's guest, Brian Kostanic, for graciously sharing his time, expertise, and knowledge. Be sure to check the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at the podcast's website, .NETCore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .NETCore.show/review for ways to do that. Reach out via our contact page at .NETCore.show/contact, or join our Discord server over at .NETCore.show/discord, all of which are linked in the show notes. But above all, I hope you have a fantastic rest of your day, and I hope I'll see you all again next time for more .NET goodness. See you again real soon. See you later, folks.